What if you could control your room light from anywhere in the world and also monitor live temperature and humidity in real time? In this video, I will show you how to interface a DHT sensor and an LED module with the XIAO ESP32C3 using Adafruit IO. First, we will remotely toggle the LEDs directly from the Adafruit IO dashboard. And then we will provide heat to the DHT sensor to see the live temperature reading instantly update on the cloud dashboard. We will build the complete IoT project step by step, so let's get started. We will require the following components for this project: XIAO ESP32C3, DHT11 sensor, LED module, breadboard, and some jumper wires. The Seed Studio XIAO ESP32C3 is a compact and powerful Wi-Fi plus Bluetooth microcontroller board based on the ESP32C3 chip. It is very small in size, but offers excellent performance for IoT and smart automation projects. It supports wireless communication, low power consumption, and multiple GPIO pins for connecting sensors, relays, display, and other modules. Connect the VCC pin of the DHT sensor with 3.3 volt of the XIAO ESP32C3. Ground pin with ground. Connect the signal pin to GPIO pin 10 of the ESP32C3. Connect the ground pin of the LED module with ground. Connect the R pin with GPIO pin 9, Y pin with GPIO pin 8, and G pin with GPIO pin 3. Now let's set up the Adafruit IO dashboard for our project. First, open Adafruit IO and log in to your account. If you don't have an account yet, simply create one for free. After opening Adafruit IO, click on the dashboard section. Then click on New Dashboard. Now give your dashboard name. You can name it something like LED control and DHT sensor monitoring. And finally click on the Create button to create your dashboard. Now click on the New Block button inside the dashboard and select the toggle block because we will use it to control our LED remotely. Since this is our first block, we now need to create feeds for the project. Create separate feeds for LED 1, LED 2, LED 3, temperature and humidity. These feeds will allow the XIAO ESP32C3 to send sensor data to Adafruit IO and receive commands for controlling the LEDs. Now select the LED 1 feed, give the block a title such as LED 1, and then click on the Create Block button. Repeat the exact same steps for LED 2 and LED 3 feeds so that we can control all three LEDs individually from the Adafruit IO dashboard. Now again click on the New Block button, but this time select the Gauge block because we want to display live sensor readings. In the Feed section, select the Temperature feed and then click on the Create block. In a similar way, create another gauge block for the humidity feed, so we can monitor both temperature and humidity values in real time from the dashboard. Now let's arrange our dashboard layout for better visibility and control. Drag and position the LED toggle switches and sensor gauges in a clean format, so everything looks organized and easy to use. Once you are happy with the layout, click on the Save Layout. Click on the AIO key. Here you will see your username and active key. Copy the username and paste it into your ESP32 code where it is required. Then copy the AIO key and also paste it in the code. These credentials are necessary to connect your XIAO ESP32C3 with Adafruit IO. Install the required libraries. And upload the code to your ESP32C3. Once uploaded, your device will start communicating with the Adafruit IO in real time. Now I have powered up the XIAO ESP32C3, and as you can see, the system is up and running. The DHT sensor is actively reading the environment, and you can now see the live temperature and humidity values updating on the Adafruit IO dashboard. This confirms that our IoT setup is working perfectly and the ESP32C3 is successfully sending real-time data to the cloud. Now I am going to test the LED control system. I will toggle the switches from the Adafruit IO dashboard, and as you can see, all the LEDs turn on instantly. Now I am turning them off one by one, and you can clearly observe that each LED responds in real time. I will repeat this on and off cycle a few times to confirm that the connection is stable and the ESP32C3 is properly receiving commands from the cloud without any delay. Now I am applying a little heat near the DHT sensor using a soldering iron, just to test the responsiveness. As you can see, the temperature readings start increasing from around 32 degrees C and it gradually rises in real time. Now it has reached up to 36 degrees C. This clearly shows that our DHT sensor is working correctly and the data is being updated instantly on Adafruit IO through the XIAO ESP32C3. Now you have seen the complete working for this project. We successfully interfaced the DHT sensor and LED module with the XIAO ESP32C3 and controlled everything through Adafruit IO in real time. We can monitor live temperature and humidity and also control multiple LEDs remotely from anywhere in the world. If you found this tutorial helpful, make sure to like the video, share it with your friends and subscribe to the channel for more IoT projects. If you have any questions and suggestions, drop them in comment below. Thanks for watching and I will see you in the next video.